Beginning in 2009, we at the Sumitomo Forestry Group have been managing a large tract of forests in Indonesia's West Kalimantan province, primarily acacias used in paper manufacturing. We surveyed the geography and ecosystems of this vast area so we could appropriately zone the forests for either conservation or harvesting. By protecting natural forests and planting fast-growing acacia trees in degraded forests, we have been able to manage our forests in a way that conserves tropical peatlands. Tropical peatlands consist of deposits composed of dead plant life that has only partially decomposed. They contain large volumes of water and carbon. Many regional plantation owners used to dig canals to drain these peatlands so they could make the land suitable for growing crops and trees. However, excessive draining caused the peatlands to dry up, releasing large volumes of carbon dioxide. They also became highly flammable, leading to wildfires and smoke damage. To prevent fires and develop a way to manage forests sustainably in tropical peatlands, we at Sumitomo Forestry designed a proprietary framework that involves managing peatlands like reservoirs. The key to this framework was designing canals that would not negatively impact the environment. First, we conducted topographical and geological surveys to create a highly precise topographical map, which we used to install distributary canals along the contour lines. In doing so, we created a model for stabilizing the groundwater level during rainy and dry seasons. In the latter case, water stored upstream can be released downstream a little at a time to ensure the groundwater level across the forest remains even. This model relies on canals placed along contour lines, spaced by 50 centimeter increments, as well as our very own water management system. The water that flows downhill in the main canal is controlled by peat dams, which are constructed out of the terrain itself and designed to block water flow up to the desired level. Building these dams allows water to be channeled into the branch canals running along the contour lines. Water blocked by peat dams can be led into spillways via sluice gates, allowing us to send more water downstream to properly manage our peatlands as necessary. We even set up simple automatic sluice gates at the heads of smaller distributary canals. Precise observations of changes in the groundwater level allow us to meticulously regulate the water volume entering every canal. It is a sustainable model for preventing drying in peatlands. As part of the peatland management project we are conducting with IHI Corporation called Next Forest, we developed real-time weather observation instruments to gather rainfall and other data to construct an AI model that can forecast groundwater levels several days in advance. We're looking to bring more peatlands under our management so we can restore more tropical peatlands. Our goal is to help create a sustainable world that benefits both the economy and environment through forest management that incorporates our technologies. By conserving biodiversity and providing benefits to local communities, forests provide greater value to the world when we manage them as natural capital.